Okay, let's work through this sample test. First, it says to convert the following units, showing the units of conversion. Convert the following: 18 feet to yards. So I want the feet to cancel, and I want the yards to show up. And so I have to decide, so this is over 1, so the feet will cancel here if I get this right. So I ask myself how many yards are in a foot or how many feet are in a yard. And 3 feet make 1 yard, so this becomes 6 yards. And I want to see the conversions. Showing units is a major part of the scoring. So you got to show how this works, not just say, oh, it's 6 yards. 1 hour, 17 minutes, and 30 seconds to minutes. So we have 1 hour. And to convert that to minutes, I have to take, let's see, I want the hours to disappear and come up with minutes. And 60 minutes is 1 hour, and the hours cancel, so I've got 60 minutes for the hour. So I got 60 minutes plus 17 minutes. And then I got 30 seconds, so I got to convert it. 30 seconds. And I want to convert it, so I want the seconds to cancel. And I come up with minutes. And let's see, it's 60 seconds make 1 minute. So the seconds cancel, and I end up with 30 sixtieths, or 1/2. So I get 77 and 1/2 minutes. Four and a half square yards. If you want, you can put 4.5. Square yards, that's yards times yards. To feet, so I need the yards to cancel and come up with feet. And 3 feet make 1 yard, but that would only cancel one of the yards, so I have to do it twice. So I get 9 times 4.5. .5 feet squared. Okay. 34 cubic meters to cubic centimeters. So I got 34 meters times meters times meters, and I got to get to centimeters cubed. So I have to get one of the meters to cancel and come up with centimeters, and that would be 100. Centimeters make 1 meter, and I have to do that 3 times. So I get all 3 of the meters to cancel, and so I got 100 times 100, which is 10,000 times 100, it's 1,000,000 times 34 million centimeters cubed. 14 cubic yards, a truckload, so I'm saying 14 cubic yards is a truckload of topsoil is being purchased to cover a 75 feet by 50-foot backyard with 1 inch of soil. How much is that? Too much or too little? So if I have 75 feet on one side times the other direction is 50 feet times 1 inch thick, and I need to make that into cubic yards. So I have to multiply by something that'll get the feet to yards, so the feet have to cancel and we get yards. And 3 feet make 1 yard. And I have to do that one. 3 feet make 1 yard. And I have to do the inches. So I have to have inches in a yard. Now I could go inches in a foot and then a foot into yard, but there's 36 because there's 3 feet, 12 inches in each foot, so 36 inches make 1 yard. So I have 75 times 50 times 1 times 1 times 1 divided by 3 times 3 times 36. So 75 times 50, then I have to divide it by 3, and then divide that by 3, and then divide that by 36, and I get 11.57, and the feet are gone, the feet are gone, the inches are gone, yards, 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 cubic yards. So if the truck brings 14 cubic yards, minus this, I'll have extra 2.43 cubic yards. An airliner travels 45 miles in 5 minutes. I want to get miles per hour. I already have miles, so all I have to do is get the minutes changed. I want the minutes to cancel. I put minutes up here, and I need hours. And I believe 60 minutes make 1 hour. So 5 goes into 60, 12. Or I could have said 45 times 60 divided by 5. 45 times 60 divided by 12. Or I could have done 45 times 12. Whoop. Oh, 45 times 60. It was 45 times 60 divided by 5. 540. 540 miles per hour. The minutes cancel and we're left with miles per hour. If a car gets 28 miles per gallon, how much does it cost to drive 250 miles when gasoline costs $4.49 a gallon. So I got to convert 250 miles to dollars because we want to know how much it costs. So 250 miles, and I want miles to cancel, so I'm going to go use this fact that 1 gallon will take me 28 miles. That gets my miles to cancel, and so that divided by that will give me the number of gallons, and then times $4.49 per gallon. And now the gallons cancel, and I'm going to be left with dollars. So I take 250 divided by 28 times 4.49. Is it okay to just write the answer? And the answer is no. You need to show me how the unit conversions work. So I need to see this. I need to see this. I need to see unit conversions. Now you can shorten the unit conversions if you know 27 cubic feet make 1 cubic yard or something like that. And you can use those factors. But I need to see how the units convert. Okay, now we got a fraction. Can I just type this in my calculator? And the answer is no. I want you to give me the answer as a fraction using fractions. So 3 2/7 minus 1 5/6. So 3 minus 1 would be 2, and 2/7 minus 5/6. So I need to do this. So I need a common denominator. Now I could have changed these to improper fractions. Some of you know that you take 7 times 3 is 21 plus 2 is 23/7 minus 6 times 1 is 6/6. 1 is 6/6 plus 5/6 is 11/6. Still need to get a common denominator, so we need to multiply this one by 6 and 6, or this one by 7 and 7, so that their denominator is 42. So I'd get 38 over 42 minus 77 over 42, which is, let's just make sure I did my arithmetic correctly, 6 times 23. So 138 minus 77 is 61 over 42. If I continue with this, I would multiply by 6 and 6 and 7 and 7, and I would have 2 and 12 over 42 minus 35 over 42. And so this would come out to be minus, so I need to borrow from this. So I'm going to borrow 1 from the tube, call it 1, and 42 42s, plus the 12, that's 54 over 42. So 54 minus 35 is 19. So I would have 1 and 19 42s, which is the same as 61. 19 plus 42 is 61 42s. So 42 42 seconds plus 19 40 seconds is 61 40 seconds. So either this answer or this answer. Order of operations. This is just a check. Do you remember how to do order of operations? So some of you know that is PEMDAS powers, parentheses, powers, parentheses, exponents, that's what it is. Multiplication and division are the same operation, so they go together in left to right order, and then comes addition and subtraction. This is the PEMDAS. So when I look at this, I have parentheses here. So I'm going to do 9 minus 5. And then I've got this parentheses. And inside there are parentheses. So I have to do these first. And this is subtraction and addition, and they go left to right. They're the same operation. So I got to go 5 minus 6, which is -1, plus 2, which is 1. So now I have 12 divided by 4 times 1. 12 divided by 4 times 1. Multiplication and division are the same order, so I have to do left to right. So I got to go 12 divided by 4, which is 3, times 1, which is 3. So I had 9 minus 5 times 3. Now, I can't do the 9 minus 5 first because multiplication comes before subtraction. So I have 9 minus 15. I have to multiply these first. And 9 minus 15 is -6. And I'll want to see that you're working this out in order. Okay. Suppose you want to install new carpet in a room that measures 18 by 22 feet. And it costs $22.50 per square yard. And they only come in 12 foot wide and at least 100 feet long. If you only want one seam, so let's make our room 18 by 22, and it comes in 12 foot wide. So if I go 12 foot wide, 22. If I go 12 foot wide here, then I'd only need 10 foot wide here, so I'd cut some off. Now I can't run it this way because then I'd have to do a whole nother 22 feet and another 22 feet if I only have one seam. So I need to roll it this way and then roll this way. So I need my 12 foot wide roll has to go 18 feet and another 18 feet, and I'm going to have extra, but I have to buy it. So I have to buy 36 foot long roll. That's 12 foot wide. And now I have to convert, so I can work that out and I can get the number of square feet. Let's just go ahead and do that. And that works out to be 432 feet squared. Now I need to turn that into square yards, but because the cost is in square yards, so I have to multiply by, I have to get both feet to cancel. So 3 feet make 1 yard, and then 3 feet make the other direction 1 yard. So I got to take this divided by 9, and now my units would be square yards, and the cost is $28.50 per 1 square yard. So now the square yards cancel. So I have to take my 432 divided by 9 times 28.50. And I get the carpet's going to cost me $1,368. So what is this number in decimal form? So a negative exponent means divide by 10. So if I got 4.20 and I'm supposed to divide by 10 3 times. So if I divide it by 10 once, it becomes, I'll write it this way, divided by 10 becomes 0.420. Dividing by 10 moves the decimal over once. Dividing by 10 the second times makes it 0.0420. And then dividing by 10 the third time, the negative exponent means divide, becomes 0.00420. So that's the decimal form. How many significant digits? Well, this one's significant, that one's significant, and if they show one after the decimal, that one counts too. So there's 3 significant digits. You are riding an exercise bicycle at a fitness center. The readout states that you are using 500 capital calories per hour. Are you generating enough power to light a 100-watt bulb? So is this more than 100 watts? So we need to convert this to watts. Remembering that 1 watt is 1 joule per 1 second. So we need to convert capital calories to joules. And if you've got your conversion table done correctly, let's see if I can find mine, just so you can see how I intend for you to use that. One calorie is that many joules. 1 capital calorie is 1,000 little calories, and one of those is 4.12, so you get 4,180 joules. 4,180 joules is 1 capital calorie. So now we've got the capital calories out, and we've got joules. And then we've got to get it to seconds. So we will put hours up here so that they will cancel the hours down here. and 1 hour is 3,600 seconds. So the hours cancel, and we're going to get 500 times this divided by 3,600, and we're curious as to whether that's more than 100 watts. So, can you see that? Yes. So I got to go 5,000 times 4180 divided by 3,600. And that is, if you could do that much, that's 5,805 approximately watts. So we're not generating enough to light 5,800 watt bulbs. So somebody's really, really putting out the power. Okay? But to burn 500 calories in an hour, that takes a lot of hard pedaling. Okay. Next page. How many square millimeters are in 3 square meters? So we got 3 meters times meters times meters, and we got to get it to millimeters. And so we got to cancel one of the meters, and that is how many millimeters? And according to our conversion table, that's 1,000 millimeters make 1 meter. And we have to do this for each one of these meters, so we have to do it times 1,000 again. And again. So all our meters cancel for our meters. Oh, square meters. I thought it said cube. Square, so we don't need that many. We just need 2 of them, square. So we're going to have 1,000 times 1,000, which is 1,000,000, times 3. We're going to have 3 million millimeters squared. Now, if you do this on a calculator, 3 times 1,000 times 1,000, you might get, nope, that works. If you get an E in it, that means times 10 to, that means exponential. How many milligrams are in 5 kilograms? So 5 kilograms. And let's see, how many kilograms is, how many grams are in a kilogram or kilograms in? 1,000 grams make 1 kilogram. And then we need to convert this, so I got to take, that would get rid of that. Now I got to get grams to milligrams. So I want the grams to go and want to do milligrams to mg. And there's 1,000 milligrams in a gram. So this becomes 5 million milligrams in 5 kilograms. Okay. 8 ounces of whiskey contains 500 grams of 70 grams of alcohol. So suppose 50% of the alcohol is absorbed into the bloodstream. So 50% of 70 is 35 grams. And we didn't talk a whole lot about this, so we got to talk about blood alcohol content. and that is measured by how many grams are in 100 milliliters of blood. That's how they measure it. So we have to work this out to see how many grams there are per milliliter of blood. So if this person has 50% of 70 goes into the bloodstream. They have 35 grams in their bloodstream and in the first hour, and a 200-pound man has 5,500 milliliters. How much does he have in 100 milliliters? So we got to get this to be 100 down here. To make this be 100, we'd have to divide by 55. Because 5,500 divided by 55 is 100. So we need to divide this by 55, so we need to divide this by 55 to get the blood alcohol content. So we have 35 divided by 55, and we get a blood alcohol content, can you see it there, of 0.63. So that's their blood alcohol content, which is considered drunk. You need to state your assumption so that I can follow your thinking for the problem. How many frogs would it take to cover the floor of the classroom? So, if you decide your frog is maybe an inch by an inch, then you would have to figure out how many inches the classroom is by how many inches the classroom is. So now I'm asking you to estimate. Now the classroom we're in now is probably about 30 feet by 60 feet. So the amount of square feet is 30 times 60, which is 1,800 feet squared. And if we have to multiply then by to get the feet squared out, we'd have to multiply by inches squared. And since every foot is 12 inches, we're going to have 12 times 12 to convert both of them. So that's 144 inches. So we're going to have 1,800 times 144. It would take 259,200 frogs if you made the assumption that one frog, boy, I'm making a terrible looking frog, uses every square inch. If each frog consumes 50 calories a day, how many watts are produced in a day by all the frogs? So 259,200 frogs times 50 calories per frog times, see, this is a capital calorie, so how many, I have to get watts, so it's joules, so I have to go there. In a calorie, there's 4,180 joules make 1 calorie, capital calorie. And so now we'd have joules in a day, and so we have to have this per day. Well, this is, we need to know how many joules, and so that's going to do this much in one day. So this is a day. Now we have to figure out how many watts, which would be joules per second. So it's this many per day. So per 1 day, let's write it there. So this would give us the number of joules, and now we have to get a day into seconds. And a day is 24 hours, make 1 day. And 3,600 seconds in 1 hour. So we're going to have a lot of numbers here. 259,200 times 50 times 4180. That's my numerator, really big, times 10 to the 10th. Then I have to divide it by 24. Then I have to divide it by 3,600. And I'm getting 3,600 watts. 20,600 joules per second. Hours are canceled, days are canceled. Okay? Number 13. A country, in an effort to reduce population growth, decided to adopt one-son policy. Under the one-son policy, a family may have children, but their last child is limited to being a son. Determine the percentage of the population that would be boys, assuming that the boys and girls are born equally. Well, this is like the one I was doing in class, and I had to rethink. So let's just assume that we had, I'm going to pick a number that divides by 2 easily, a big number. So I'm going to do 64 families. Okay? So if I have 64 families, and they all have kids, and they all stop with a boy, there will be 64 boys. Because they all stop when they have a boy. So each family will have 1 boy. Now, half of them will have a boy on the first birth. The other half will have a girl on the first birth. So there'll be 32 girls after their first birth. Then half of the 32 will get their boy next, but the other half will get a girl. So there'll be 16 families that will have a second girl. So there'll be 16 more girls. And then half of these will have a boy as the next one to be done. But half of these will have a girl, so there'll be 8 more girls. And then half of these will have a boy, but the other half will have another girl. And so that'll be 4 more girls added. Then half of these will have their final kid, a boy, but half of these will have another girl, so there'll be 2 more girls. Half of these, one of them will have a boy, and the other one will have a girl most likely, and so there'll be 1 more girl. And so then they're either going to have a girl or boy, so it's pretty much going to be done by that. So you can see that now we get 32 plus 8 is 40, plus 16 is 56. 60, 62, 63. We're going to get about 63 girls. And so they're going to be pretty much evenly split. And that's how you get the idea that, okay, if you do a really big number and do the same thing, half plus half plus half plus half plus half plus half, you end up with the same number of boys and girls. And so you end up, or very close to the same. So they end up being 50% boys and 50% of the population is girls. Okay. Final page. Brothers and sisters, I have none. So there's somebody. One of the problem-solving techniques, draw a picture. Somebody that has no brothers and no sisters. But that man's father, so if this person is looking at someone, let's say they're looking out here, this man's father, so we go back one, here's father, got a beard, gray hair. This man's father is my father. That man's father is my father's son. That man's father is this guy's father. That man's father is my father's son. So this man's father is my father's son. So this is the son to this guy. And that man's father is my father's son. So he has to be this guy. That man's father is my father's son. So this father's son is this one, and since he has no brother and sister, he has to be the father of that man. Who is that man? His son. So I drew a picture to try to help me understand that. You have 12 gold coins that look identical, but you are correctly told that one is heavier counterfeit coin using a balance. So a single pan balance. You're going to balance. So you can only match things against each other. What is the minimum number of weighings or comparison of weights that would be necessary to find the bad coin? So if you got 12, so again, I'm drawing a picture. If you take 4 of them and 4 of them and put 4 here and 4 here, if they balance, the heavier one's not here and has to be in this group. If they don't balance, then the side that goes down, whichever one of these piles, will have the heavier one. So in the first weighing, if you put 4 on one and 4 on the other, you're going to find out that one of these 4 or one of these 4 or one of those 4 has got the heavy one. So once you know which 4 has the heavy one, then you'll put then you have to decide amongst the 4. So what do you do? So if you've got 4 and one of them's heavier, Can you put 3 on and know anything? Or you can only put either 1 on in each and find out which is heavier, or can you put 2 on this side and 2 on this side, and then whatever 2 goes down, that will have the heavier one. So that's the second weighting, and then you'll be down to 2, and then you'll have to weigh those to find out which one's heavier. So it takes 3 weighings. I don't think you can do it in 2. Let's see, if you did 6 on each side, you'd be down to 6. Then if you put 3 on each side, you'd be down to 3. And then you could put 1 on each side, and you can do it again. It'll take 3 weighings. So whether you put 4 on or 6 on to start with, you'll know you'll still have to take 3 weighings. Okay. 3 guests check into a hotel and pay $30 for a shared room. A while later, the desk clerk realizes that the room was only $25. This is an old story. That's why it's so cheap for the hotel room. So they decide, oh no, it's only $25. So the clerk, the desk, Desk clerk gives $5 to the bellhop to give to the 3 men. So there's $5 going to the 3 men. Well, the bellhop says, 3 men, what are they going to do with $5? So he takes 2, or she, whatever the bellhop is, and gives 1 to each of the people. So now each guest has paid $9, right? Because they got $1 back. And the bellhop, so that's 3 times 9, which is $27. And the bellhop has $2. So that's $29. Where did the other $1 go? The problem is we're not adding the right things together. And this is, where's the extra $1? So each man paid $9. So that's $27 each man paid. And so that's in the kitty at the desk. And let's see, get this right. No, at the desk, each is $25 because the desk clerk kept the $25 and gave $5 back, of which $2 went to the bellhop and the $3 went back to the people, and so that makes the total $30. In other words, the $27 plus the is how much the people were out. The $25 at the desk and the $2 the bellhop has, they got their $3 back, plus the $27 they paid makes the total $30. So we were adding the $2 to the $27 instead of to the $25 to make the $27, plus the $3 to make the $30. Okay? So you don't want to add the $2 to the $27, you want to add it to the $25 to make $27 that they paid. Okay. 3 problem-solving strategies. Make a picture or diagram. Simplify the problem and solve it. Look for patterns. Let's see, what did we do here? Draw a picture, simplify, look for patterns, look for multiple solutions. And anyway, there's lots of them there, okay, that we've been talking about.